Two houses on the same street. Same size roof, same panels, put up the same week by the same crew for the same €12,000. 10 years on, one of them has paid for itself and started quietly making money. The other is barely halfway there. Nothing about the hardware explains that gap. What splits them is the roof each system sits on and the life lived underneath it. Meet Anna and meet Ben. By the end of this, you will know which one you are and the 5 numbers that decide it before you sign anything. This is Spend It Once. You are about to spend serious money, so let's make sure you understand exactly what you are buying. So, are solar panels worth it? That question has no answer, and anyone who gives you a clean one is selling something. Worth it depends on your roof, your habits, and your local prices, which is the whole reason the same panels made Anna money and left Ben waiting. The honest question is narrower. What is the payback on my roof? And that is not a guess, it is a short sum with 5 inputs. How much sun your roof actually catches, what you pay for power today, how much of your own solar you use the moment it is made, what the grid pays you for the rest, and what the whole system costs to put up. Miss one, and your payback is fiction. Get all 5, and you can check any quote in about a minute. So let's collect them, one at a time, with Anna and Ben as our 2 test houses. Number 1, and the biggest, how much will your roof actually make? We measure that in units of energy called kilowatt hours, the same units your electricity bill is counted in. And it is almost pure geometry. Which way the roof faces, how steeply it tilts, and what throws shade on it through the day. Anna's roof faces south with clear sky, so in a German climate, it pulls in around 1,050 of those units a year for every kilowatt of panels she installs. Ben's main slope faces east and loses every afternoon to a neighbour's chimney, so his roof manages closer to 700. Same panels, a third less harvest, before a cent of money enters the room. Here is the part that matters most. You do not guess this number, and neither should your installer. There are free public tools that already hold the sunlight history for your exact coordinates. The big one in Europe is run by the European Commission. You draw your roof, it hands you your production. Any installer quoting without one is guessing with your money. One honest footnote. A system labelled 10 kilowatts does not deliver 10. Heat and wiring losses bleed it down to about 80 to 85%, even on a good day. Not a scam, just physics, and a decent calculator already bakes this haircut in. Which is one more reason to trust its number over the salesperson's neat round one. Numbers 2 and 3 travel together, and this is where Anna and Ben really split. 1 unit of solar is worth wildly different money depending on what happens to it in the first second of its life. Use it the instant it is made, running the fridge, the oven, the car charger, and it is worth the full retail price you would have paid the grid, about 39 cents in Germany today. Let it flow out unused, and you get the export rate, the price the grid pays you, which in Germany is just under 8 cents, locked for 20 years. Same unit, nearly 5 times the value, decided by timing alone. So the number that quietly rules your whole payback is your self-consumption, the share of your solar you personally use as it is made. Anna is home through the day with an electric car sipping sun on the driveway, so she keeps close to half of hers. Ben leaves at 8 and gets back at 6, so with the house empty and no timers running, only about a quarter of his stays home. And one hard thing that changes with your country, whether you can sell the surplus at all. Germany guarantees that export rate. Parts of the United States now pay you a fifth of retail or less, and the 30% federal credit that used to sweeten a deal there has just expired. The Netherlands still swaps 1 for 1, but only for another blink. Before you count a single cent of export income, find out what your grid actually pays, because in some places, the honest answer is close to nothing. Now the good news, and it is aimed straight at Ben. Of those 5 inputs, 1 is not fixed by the sky or the state. It is your self-consumption, and it moves with your habits. Every load you drag into daylight turns a unit you would have sold for 8 cents into a unit you keep worth 39. Dishwasher on a timer for noon. Washing at midday on the weekend. If you drive electric, Charging off the roof on a sunny afternoon is the single biggest lever a household owns. If you run a heat pump, the machine from our last episode, let it warm your water tank while the sun is up, and you are pulling the same trick with heat. Do a few of these and Ben's meager quarter climbs toward 45, even 50%, which is worth more to his payback than bolting on extra panels. One more lever, and you choose it on the day you install. If your evenings are when power costs most, panels facing west catch that late sun exactly when it is dearest. South makes the most units, west often makes the most money. Anna got lucky with her roof. Ben has to be clever with his habits. Both of them can still win. You already know what a battery is, so let's be quick and honest about it. A battery does not make more solar. It time shifts it, catching your midday surplus and handing it back after dark, which can push self-consumption past 70%. Genuinely useful, but at roughly 700 to 1,200 euros for every unit of storage installed, in most homes today, it lengthens the payback by 3 to 5 years rather than shortening it. So buy one for backup, for independence, for the quiet. Just not because the spreadsheet demands it, because right now it usually does not. Yet. And that word is doing real work. As grids fill with cheap midday sun and export rates drift towards zero, storing your own power is slowly turning from a luxury into plain arithmetic. 2 lines of fine print. A typical home battery keeps your fridge and your lights alive in a blackout, not your heating, and not for long. And a normal solar system shuts itself off the instant the grid dies, on purpose, so it cannot electrocute the crew repairing your street. If you want power through an outage, you need a hybrid inverter. The inverter is the box that turns your panel's power into the kind your sockets use, and the hybrid sort can keep running when the grid is down. Ask for it by name. 2 last costs the sunny slide leaves out. First, that inverter again, the box that turns your panel's power into the kind your sockets use. It is the hardest working part of the system, and it usually gives out once, somewhere around year 12 to 15. Pencil in 1,000 to 2,000 euros for the swap, because your payback slide will not. Second, the waiting trap. Panels improve by about 0.5% a year now, so holding out for next year's model trades real savings today for a rounding error tomorrow. So here is the rule. Unless prices are about to drop sharply, buy this year. A year spent waiting costs you a whole year of savings to gain 0.5%, and that trade never pays. The panels do fade, but slowly, a small fraction of a percent a year, so the roof you buy now is still doing honest work in 25 years. The best panel is not next year's, it is the one already on your roof, earning. So, should you sign? 3 tests, all free, all doable this week. Test 1, the production test. Get your yearly output from a calculator like the European Commission's, not from the salesperson's slide. If the quotes number sits well above the calculator's, ask why, in writing. Test 2, the value test. Take your own retail price for the share you will actually use, your real export rate for the rest, and blend them. If a quote assumes you will use half your solar while your house sits empty all day, it is selling you Anna's roof and charging you for it. And check the boring question first. Does your grid pay for exports at all? Test 3, the whole life test. Add about 1,500 euros to the system price for the inverter you will replace around year 12. Then divide that total by your honest yearly saving. Under 10 years, sign happily. 10 to 15, fine if you are staying put, because the panels outlive the wait. Over 15, something is off, and it is usually the roof, the price, or a habit you can change. Anna passes all 3 without trying. Ben fails the value test today, but he does not walk away. He moves his washing to noon, points half his panels west, and passes it next week. That is the whole point. You are not buying Anna's luck. You are running your own 3 tests. The shape of the money, our 2 roofs, German prices today. The same 12,000 euro system on both. Anna's south roof and daytime life value her solar at around 22 cents a unit, so she claws back roughly 1,800 euros a year and breaks even a little after year 7. Ben's shaded roof and empty house value his at around 15 cents, under 900 a year, so he does not break even until around year 15. Same panels, same price, 8 years apart, decided entirely by the roof and the routine. Your version sits somewhere between them, and you now know the 5 numbers that place you. Pull them, blend them, and the quote has nowhere left to hide. So here is the whole game. The panels were never the question. They work, they last, and they are cheaper than they have ever been. The question is the roof they sit on and the life lived under it, gathered into 5 numbers and 1 minute of honest arithmetic. Get a real production figure, value your own units properly, and remember the inverter. Do that, and solar stops being a leap of faith and becomes what it always should have been, a calculation with a warranty. If a purchase you are about to make deserves this kind of breakdown, subscribe. Next time, electric cars, and Anna and Ben are buying again. Everyone argues about the sticker price, and the sticker is the least interesting number on the deal. The real money hides in what the car is worth on the day you hand back the keys. Until then, spend it once and spend it right.